Hello, this is a demo from Qing. The topic is to use cplex to solve the optimization problem. In this demo, there are three problems: assignment problem, transshipment problem, Marquis mean variance portfolio model. We always ask four questions to solve an optimization problem. What is the known information in this problem? What are the decision variables in this problem? What are the constraints on these variables? What is the objective? Now let's see a simplified typical assignment problem. A company wants to assign three workers to three jobs. Each worker will receive different payment for doing different jobs. From the company's perspective, the objective is to minimize the total cost spent on each job. To solve this optimization problem, let's analyze the four factors I mentioned before. The known information is the cost of each worker assigned to each job. If we use I to identify workers, use J to identify jobs, the variable is cost ij. Because we want to know which worker should assign to which job, so here the decision variable is assign ij. If worker I assigned to job J, let assign ij equals 1. If not, assign ij equals 0. So assign ij is following type variable. The objective is minimize the cost of each job spent on corresponding worker. Mathematically, the objective is to minimize sum of assign ij times cost ij. The constraints of this problem are: each worker can just assign to exactly one job mathematically. That is, for any I in workers, sum of assign ij must equals 1. One job can just be occupied by exactly one worker. Mathematically, for any j in jobs, let sum of assign ij equals 1. Thus far, we can transform what we analyze into programming language in cplex. As you can see, this is a cplex interface. First, we define the number of workers and the number of jobs, and define the cost of each worker assigned to each job. The data of cost we'll get from external, and then write down the objective and constraints. After run the configuration, we got the result. Assign worker 1 to job 1, worker 2 to job 2, worker 3 to job 3. The combining will get the optimal result. Next, let's see the transshipment problem. This problem is similar to assignment problem. We know a company owns three plants. Each of them has a maximum amount of production, and four cities demand the product from the company. Each city has a minimum amount of demand. Also, we know the cost of each unit of the product shipped from a plant to a city is different. So the objective is to determine the minimum total cost of product shipped from a plant to a destination city. Now let's see the model in cplex. First, we define the minimum demand of each city, the maximum supply of each plant, and the unit cost of shipment from plant I to city J. Then define the amount of product shipped from plant I to city J as the decision variable. The objective is to minimize the sum of ij times unit ij. The first constraint is the total amount of product shipped from different plants to each city must more than the minimum demand of the corresponding city. The constraint is the total amount of product shipped to different cities from each plant must be less than the maximum supply of the corresponding plant. After running this configuration, we will get the optimal amount product shipped from each plant to each city. Then let's see the Marquis mean variance portfolio model, which is a financial optimization problem. The goal is to choose the portfolio weighting factor optimally. Let's analyze the problem from the four perspectives. The information we have known is the historic price of different stocks. Then we can calculate the average rate of return, variance of each stock, and covariance between two stocks. The decision variable is the weight of each stock in the portfolio. The objective is to minimize the volatility. Mathematically, the volatility of the portfolio is the covariance between ij stock and times the product of the weight of these two stocks. There are two constraints. First, the average rate of return of the portfolio should exceed the acceptable baseline accepted rate of return. Second, sum of all weight of the stock in the portfolio equals 1. In cplex, first define the stock type, target, which is the expected rate of return, the covariance of two stocks, and the average rate of return of each stock. Then define the decision variable, weight of each stock, which is the positive flow type. Then then this the objective and constraints I explained before. After running this configuration, we can get the weight of each stock in this portfolio. That's my demo. Thank you.